Welcome everyone to this June meeting of the Zero Carbon Mine. Today we're going to be talking about, got a bit of a panel on mining electrification, specifically on the mining equipment, smaller probably end of things. We're going to talk about the challenges and opportunities with that. So these webinars were really just about focusing, encouraging collaboration around sort of the shift towards the the zero carbon emission industry. Excuse me. And just we want to be able to want to be facilitating these sorts of discussions, panels and interviews and the like. So yeah, I'll sort of hand over to introduce a few of our guests on the panel today. We've got Anthony Bettanin, MEVCO over in Austin, Texas.
Everyone.
Got Tanya Nassir, sort of from 3ME Technology in Sydney way, and Patrick Marshall, sorry, from Maclean Engineering, up in Queensland. So I thought I'd just start, go through you guys and give a bit of an introduction, your background, and tell us where your sort of technology is at, and how's it getting out there in the industry, and future, sort of where you sort of currently are and what sort of the plans are going forward. Just as a bit of a quick overview to start with. Start with yourself, Anthony.
Hi there, everybody. Anthony Bettanin, Chief Operating Officer of MEVCO, Mining Electric Vehicle Company. So it's all in the name. That's what we focus on exclusively, light vehicles for mining. We operate in Australia, the US and Canada. And in Australia, we offer two vehicles. We offer the Rivian R1T, which we import in left-hand drive form from the US for off-road applications, and the Toyota Hilux, which we convert using the X-Row kit to full electrification for homologated on-road use in Australia.
Tanya?
Yeah, hi everyone. Good morning. Tanya Nassir from 3ME Technology. I'm the Business Development Manager here, and I've been with the company for 3 years. 3ME Technology is a battery manufacturing and an advanced systems integrator. We provide turnkey solutions into the mining industry. So that ranges from battery electric kits that could be provided, retrofitting at all different form of levels, battery technology, so an agnostic battery system with immersive cooling technology, as well as we've got the Blade Drive, which is a proprietary software system that overrides electric kits and allows you to have all the electric components communicating cohesively. We've got charging solutions specifically for underground mining, and we've recently launched the Blade Charge, which is an off-board charging system as opposed to the on-board charging system that we're currently using in our assets. We've got around 15 to 20 assets deployed in the Australian mines at the moment. You've got the electric loader, so it's a Volvo L120 that's been retrofitted, tested in the underground mine. We've got the batteries in the light vehicles, the Bettanin, which you might have seen around as well. And there is also some hybrids being implemented in the defence industry, as well as some other assets in the aerospace. In terms of future plans, I guess we're looking at standardizing our kits across the loaders, looking to play a bit of a bigger role with the larger equipment as well. And then collaboration around recycling has also been a bit of my focus recently. I think that's about it.
That's good overview. So he's definitely getting out there in different spaces. And so, yeah, Patrick.
Thanks, Brett. I'm Paddy Marshall, Vice President of Technology with Maclean. I've been in the industry for about 15 years, 5 years with Maclean. In Canada, I ran product management. In moving back to Australia, I'm here to support the deployment and the success of our new vehicles, our new technology. Maclean build underground mining vehicles, so ancillary, utility, shotcrete bolting, secondary brake. With our BEV story, we got into EVs in about 2015. We built our first battery electric bolter. Deployed now through Canada, Mexico, South Africa, Australia. We've got more than 70 machines deployed, 20 different vehicle types electrified. We have 4 BEV fleets established in North America, so 10 to 20 vehicles per mine site. Those are the Odyssey mine up in the Abitibi at Canadian Malartic. We got Onaping Depths with Glencore and Sudbury, Borden Lake, Timmins, Newmont, and west of Timmins, and Media Luna in Mexico, Torex. We electrify everything we do, but we're now taking our electric drivetrain and also introduce it into some surface equipment. So that's a new project we're standing up. Just on mute there, Brett.
You're on mute, Brett.
I thought I turned myself off, but I put myself on. Thank you. So yeah, it seems like there's a lot happening, but I suppose I'm really curious if it's still a tough journey getting EVs out into the industry. Replacing the diesel sort of equipment. I suppose it's like what sort of how hard are those barriers to, and whether or not your thoughts on whether or not the industry really grasps the benefits of switching, and whether or not the cost benefit might not be quite there in some instances, but I suppose it's getting your thoughts on those challenges of electrifying the industry. If anyone has any thoughts there.
Sure. So from our perspective, we find the biggest barrier and the first question we're always asked in terms of battery electric light vehicles is, what's the lifespan in a mining environment? And we haven't yet got any of our vehicles that have come to the end of their lifespan, so we can't give an evidence-based answer to that question. And miners are naturally risk averse, and don't want to be the first, and always want to look to make sure that things are going to be robust enough for their environments. So that's the stage that we're going through. We're going through a lot of trials where they're testing it in their environment. They really want to see that it holds up to, we've got miners that are testing it in the extreme heats of the Australian and the US deserts, in the extreme cold of Alaska and Canada mines, extreme altitude and so on, or, even extremely corrosive environments, salt mines and so on. So every mine has its own challenges, and we certainly find that miners want that proof point, and we think that once we reach that tipping point where there is actually enough proof around the longevity and performance of these vehicles, that things will change very quickly. But at the moment, everybody naturally wants to make sure that it will be suitable for their environment before they take the plunge in a major way.
Yeah, I think I want to echo your point, Anthony. I think you mentioned a really good point, which is each mine has its own challenges, and we oftentimes try to have a conversation around that when not one size fits all. And I feel like with our journey, given that we are retrofitting and providing kits and batteries going into OEM equipment, it's more around, okay, so what type of data do you have about the duty cycle, the performance, chemistry performance within temperatures, and then you have to provide evidence, but it's mostly either simulations or evidence from a different mine, but that doesn't mean it'll perform exactly the same in your duty cycle and your conditions as well. Plenty of factors play a role in there, your ventilation system, your incline, all the different components. And then, we've noticed that it's become more of an educational journey around what the adoption of electrification and electrified equipment actually looks like, and what is that conversation around total cost of ownership uptake, just given all the different variants that play a role within the mine design as well. So yeah, that's definitely been a challenge of ours. And then yeah, not to mention some of the chemistry conversations as well in terms of implementation.
Yeah, that is one of the questions we've just got popped up. You know, like what are some of the concerns that customers are raising around safety related to battery chemistry? Is that something you guys come across?
Yeah, every time.
Yeah,
you
all
know,
the time.
I onboard a lot of customers through our risk management process. You know, if I was to go through the same question, what are our barriers? For our vehicle types, you know, I would say the barriers to adoption are not related to the technical solution. The technical solution in most hard rock mines, in the duty cycle and the application type that those vehicles go into, it's not the barrier. It's an understanding of risk management, productivity, total cost of ownership, total mine performance when you look at system level performance. But yeah, the going through the risk management onboarding process, the chemistry does, it always comes up as the first topic, chemistry or just fire management. And it's important to cover as a topic, but it's probably not the critical risk that you're going to drive fatalities from. There's, you know, electrocution is a has much more higher probability if you don't have the right controls to occur. All these battery systems, regardless of the chemistry, the actual controls are in the battery management system typically. So the designs around the battery management system are more important than the particular chemistry that it's controlling for.
Fair enough.
Yeah, so we certainly find that the underground miners that we speak to are much more sensitive to battery chemistry than the surface miners. So, you know, a lot will insist on a different chemistry for underground compared to what they're prepared to accept on the surface. The other question that we get a lot is around penetration testing for the battery enclosures themselves. So that's that's also a big question in the mind of miners. They're very used to having penetration incidents with their existing ICE-like vehicles, and they want to know what sort of effect that will have on a battery electric vehicle. So we often find that when they see the Rivian R1T in particular in person, and they have a look underneath, and they see that it has got an underbody shield that is practically flat. There's nothing for it to catch on, and that's before you get to the actual battery enclosure itself. That certainly generates a lot more confidence compared to what they're anticipating seeing. I think from an electric vehicle.
Yeah, I think I usually follow the onion peel method with my clients, in which we talk about battery chemistry, but it's not a standalone, as Patrick mentioned. It's actually how you manage the battery chemistry. So on top of that, you have the adequate hardware, which is a lot of your mechanical controls, your isolation, your ingress protection, enclosures, dampeners for vibration, whatever it is that you may put in place. And then after that, you've got your battery management system, which I call the battery brain. It basically protects it from anything in and out, and then it allows it to have that efficient operation. And then on top of that, there's another layer, which is your temperature management system or your thermal propagation management system. And then once you kind of visualize that, then it gives the customers a bit of more understanding around how things are managed around the vehicle, the functional safety of the kit itself on top of the battery itself, and so on. So yeah, a lot of the conversations happen when a lot of the visitations to site occur. You get to feel and touch the technology, and you see how the battery behaves. You see the immersive cooling technology. You start to understand a bit more of the safety level, as opposed to it just being a black box.
Yeah, that's it's certainly part of every risk assessment process that we've been through so far.
Yeah.
Yeah, and as you say, the battery management system is crucial to that overall safety profile. Yeah, one of the challenges again we find is mines want mine-specific safety information. So whilst we're able to give a lot of information about the batteries and the fact that there are tens of thousands of units out there running around and operating safely, and we can give percentages of battery fires and all those sort of pieces. When they then ask, okay, well, what about data that's specific to mine environments? Again, because it's early in that cycle, it's hard to provide enough data to satisfy that with the existing fleet. So, as more critical mass is reached, that I think will accelerate the tipping point.
Definitely big education sort of piece on what is sort of about the technology, but also there's a lack of data of what's actually been out in industry, like particularly like underground mines or in Australia, like they want it quite localized so they compare. So it's a big barrier. And how long, or what sort of, how can we get over that, I suppose, in the shorter term?
Yeah, well, so recently I was actually up at the Rivian factory in Normal, Illinois. We were doing a plant tour for some mining customers, and as part of that, we got to see the battery manufacturing area. And it was interesting to see the change in those mining customers after they saw the way it was constructed. I mean, it's one thing to talk about battery management systems and and barriers and all that sort of thing. But when they could actually see, just how much was there around the cells, all the technology that goes into protecting it, how robust, all of that is, how thick the casing, and seeing that battery in all those sort of different stages of, sort of half assembly and so on, that certainly generated a lot of confidence. Another thing that we've found is we have access to the Rivian skateboard, right? So that shows just the vehicle platform at the bottom. So you're seeing the battery surrounded by the chassis, how that fits together with the underbody shield and all those sort of pieces. And again, we've found that when our mining customers have seen that, that's generated a lot of confidence. It's like your comment, Tanya, when they can see and touch it, it becomes less scary, right? They can then understand the engineering that sits behind it, and they can start to visualize how that will fit into their unique mining challenges. But when it's just presented to them as a sort of an end product where all that is hidden away, they're not prepared to take that leap of faith.
I think another way we've managed to get around that slightly is we've introduced what we call a battery 101 module that we go through with our clients, and that's kind of paired up with our new testing facility. So we've got a testing facility at the moment that is capable of testing batteries on a full battery system level, so not just a cell or a module, but just imagine larger packs anywhere between 70 kilowatts to 120. Don't quote me on that, probably the range is a bit off, but basically what we've done is we've conducted this exercise with a miner where we've tested 6 to 7 different battery technologies, and we're doing duty cycle testing, critical testing under environmental chambers with temperature and everything attached to that. So we're mimicking the exact conditions of their mine and their duty cycle requirements across different chemistries and different battery technologies as well. They also have different cooling systems, so we're just showing them that standardization in terms of its standardization is viewed a bit differently, because all these different technologies might actually be fit for the duty cycle. It just depends on how they handle their temperature, how long they last. So that testing facility has actually served a much larger purpose in terms of being able to collect data against a specific duty cycle, but with all different technologies.
Mm-hmm. Yeah, we've certainly found that showing miners those sort of testing results have been important. Everything through from the high-tech stuff you're talking about there through to even the much lower tech stuff where, we're doing thousands of kilometers on shaker roads to show the impact of how they'll operate in those real world conditions over time.
I think what we're talking about here largely as the barrier is people are short of the knowledge they might need to make the decision. In North America, what I've seen is miners, contractors start with 1, 2 assets, start small, start early, and they build their knowledge base. There's a huge amount that goes into introducing electric vehicles to site in terms of procedures, training processes, just experience in operations, the driving feel of electric vehicles, charging practices, managing state of charge, planning for electric vehicles, electrical infrastructure for electric vehicles. And you're not going to do that for a fleet off the bat because you won't have the experience. And starting with a single vehicle rarely makes sense economically. It's not going to, because you're not seeing system level benefits, but it builds up that knowledge base. So when you jump to more than single vehicles, you're actually ready to do it. So in North America, the big miners, Glencore, Agnico Eagles, New Gold, they started small. They started early. And now they're all in the process of deploying multiple vehicles because they got their site readiness up for this big transition, this big shift in technology.
I also, with all that learnings about the technology and how it's applied on site, is there, sharing of information across mine sites and between OEMs and all that sort of thing? Do you see a bit of that sort of happening to help? Educate people.
I think in the Sudbury Basin between Glencore and Vale, they collaborated a lot between 2017 and 2020 to co-author a battery electric vehicle specification through industry organizations. GMG, there was a lot of collaboration to multiple OEMs and mining companies to put together the first, second, and third volumes of the GMG battery electric vehicle guidelines. And it's still a great resource to turn to, summarizing some of the early knowledge. So yeah, even in risk management, when there have been, battery incidents, that's seen miners and OEMs come together, even those that weren't involved, to share the knowledge, review each other's risk management documentation, look for where the holes were, and set new standards, new specifications to ensure it doesn't happen again.
Got a number of questions coming through on the chat here, like one, go back to one from Andrew a bit ago, with the technology, change, rapid changes in technology, with the rate of change being faster than the sort of life cycle. How are you sort of managing sort of I don't know, you can read through Andrew's question there.
It's probably less of a challenge for us than some other vendors because we're focused exclusively on light vehicles, and because light vehicles in a mine environment, typically only have a 3 to 5 year life cycle. A lot of the miners sort of see them as something that's almost consumable, right? It's constantly they're turning over that fleet, so it's not as big a consideration for them. It's not as if they feel like, oh, I'm buying a light vehicle now, and how is this going to operate in 10 years' time? They're not sort of looking at that horizon. But Patrick and Tanya, I imagine with the equipment you're supplying, it's a different equation.
Yeah, it definitely is a bit of a different equation for us. So to your question, Andrew, we do two things to try and get around that. First of all, we invest in chemistry and battery cells that will last longer and give us that cycle life that we require for the vehicle. After we obviously do quite a lot of analysis on the duty cycle, we choose which chemistry is best fit. So we are technology agnostic and chemistry agnostic in our batteries. They're designed to take any form of pouch cells, majorly around LFP and NMC. That's where we would play for the underground, just because of weight and some other trade-offs associated with LTO. But in terms of hardware as well, we design our blade drive and our integration systems to be modular so that they could accept any type of chemistry coming in. And in terms of, it's more of a software question. It's just software updates to then recalibrate what that looks like for the battery chemistries, you know, min and max dynamic temperature changes and things like that. So that's how we go around it. It's more of a risk assessment based design around what new technologies might arise and how do we then change to that. And it's all part of the sustainable design approach as well.
Yeah, and you know, simulation will inform a lot if a current technology or asset in a particular duty cycle will work for any given client in their particular mining operation. And if the duty cycle and the performance meet your requirements, then the future iterations of the technology don't actually matter that much, because you can realize an economic benefit now, you can realize a health improvement to your operators now. Our first battery systems were 93 kilowatt hour battery systems. So we've increased about 50% to 134 kilowatt hour on our vehicles, but it doesn't really change how the vehicles get used, because our vehicles drive to a heading, park, and they plug in and use onboard chargers to charge. So the application and design worked from very early on for the mine sites that were adopting them. With these larger batteries, now the tramming range has increased, so the number of mine sites that these vehicles might be applicable for has increased. Once the technology works for you now, being concerned about future technology coming down the pipeline is kind of like waiting for any other technology. It's waiting for the new phone or the new bike or the new car. You're missing out on an economic benefit, performance benefit, productivity, or health benefit now while waiting.
We had a question from Julianne back a little bit about how, you know, your BEVs are coping like underground, the high temperatures. Anyone want to comment on that?
Yeah, so we don't find that to be an issue at all. You know, underground, you know, the sort of temperatures, the magic 32 degrees wet bulb temperature, that's no challenge at all from our perspective for a battery electric vehicle. You know, where we've got miners that are operating at 40 or 45 degrees on the surface in the full blazing sun, that's much more of a heat challenge than what it is in an underground mining environment. The second part of the question was around, comparing that to systems being designed for diesel plant. I mean, we actually find the opposite, right? The underground miners that are looking to adopt the electric-like vehicles, one of the reasons they're doing that is actually to reduce the heat load inside the mine, because for every diesel they take out, obviously that's less ventilation, both from an exhaust, but also from a heat perspective. So, one of the large miners we're speaking to in Canada at the moment, they've already got a deep underground mine, and the next ore body they want to access is considerably deeper, and they are ventilation constrained. So they've worked out that the only economical way that they can access that next ore body is actually if they switch to electric vehicles, so that they can reduce the heat load that's being generated, so that they can operate within their ventilation constraints.
Yeah, for ourselves, liquid cooled batteries, you have a temperature management system. For surface operations, that's where we're seeing the same heat exposure. We just add an active chiller. So we strip heat in the 40 to 50 degrees ambient temperature range to operate on hot surface and underground. I mean, you're typically getting to tools down in those higher heat categories.
Yeah, definitely. I think it's a temperature management system dependent type of question. So for us, we use immersive cooling technology and liquid cooling as well. So we see that the temperature internal to the battery holds itself very well. We're just concerned about the inlet temperature of the fluid or the inlet temperature of the liquid coolant that you're using, as opposed to too much the outside. Same comments as Patrick and Anthony. Underground hasn't been an issue. I think it's operating on the surface in the sun or being left parked in the sun for a very long time, and these type of the questions that we get asked, as opposed to it being underground. I think the ventilation system underground is pretty well equipped for the electric vehicles that we're retrofitting.
Well, and like, you know, definitely the benefits of BEVs compared to diesel, but like, curious, like, what sort of opportunities, I suppose you said, Anthony, about being able to go deeper where you might not have been able to previously and all that, but what other sort of opportunities is that raising in the sort of mining industry, you know, with that slow sort of switch to electrification, anything that you guys sort of see?
Permitting, I would say that it can land well with the communities you operate in, so it can accelerate permitting. So Borden, which was Newmont's property that went out to try and name themselves first all-electric mine, they argued that they got their permits 12 months earlier than had they put forward a diesel mine plan, because of their proximity to the community. They're based on a beautiful lake up in northern Ontario. So I think it's a tangible benefit, huge increase to net present value when you can accelerate a project like that.
I think there's also an opportunity to push some of the technology advancements around connectivity in the underground and just connectivity of site. A bit more thinking around the design of the communication systems and mine design. I think there's a question here is, do you see any opportunities to change the way we design and construct the mines? Absolutely. I think to Anthony's point, you can go deeper, reducing the diesel particulate matter underground in a confined space. Obviously, you could bring in more assets. So you could, you know, go smaller assets, just more of them, or change the way the operation is set up, because you could get more vehicles underground. Same thing with your support, ancillary vehicles and so on. So definitely there is an opportunity there. Also more thought around fleet management systems and it being automated. Obviously electrification of the asset allows, you know, a greater degree of automation and just designs around what that might look like in the future using AI and some, you know, learnings around that.
And I think we also shouldn't underestimate the effect on operator comfort. You know, that's a big one where, you know, mines are often in a very competitive market for talent, and, you know, particularly in, you know, if you've got operating a mine in the Pilbara or somewhere like that, you know, if you've got an advantage in having a more comfortable environment for those miners to operate in, and, you know, they'll choose your mine because there's more electric equipment, I think that's really significant. Yeah, nobody wants to be around diesel exhaust all day. And even for others that might not have sort of frontline duties, if it's a supervisor at the pit or things like that, people who are using their light vehicles effectively as a mobile office, it's a lot more comfortable to be doing that sitting in an electric vehicle than what it is idling in your diesel vehicle for hours on end at the, overlooking a mine site. So there are, but your point was really interesting, Patrick, in terms of the community that's around the mine. But I think, bear in mind the community that's in the mine is also a big selling factor.
Other design opportunities kind of exist in grade, like you can potentially target steeper grade just because these vehicles are faster on grade. They can handle higher speeds at steeper grades than diesel can. You got the opportunities to take advantage of gravity So where appropriate, where your ore handling system is designed to support it, you can look at down ramp haulage, and try to create those energy infinity loops where you regenerate energy on your down ramp with payload and have less up ramp payload, so you realize net zero energy consumption or very low energy consumption for the circuit. Big changes to your capital infrastructure in underground. If you look at exhaust raisers, vent raisers, vent heating and chilling systems, the amount of primary and auxiliary fan infrastructure you've got to run, time spent installing that, or your services to install that. Big opportunities in energy management and power management and how you lay out your power infrastructure. Likely need to actually put a focus on this and put in a better quality energy management system for load management to realize some benefits of a fully electric system, and to protect your electric assets and sensitive electronics where it needs good quality power within spec power.
Yeah, I think that also ties into one of the other questions in the chat around the opportunity to design mines so that they're better suited to electrification. So for a lot of the underground miners we've spoken to, they initially start by thinking in terms of putting some of the charging infrastructure on the surface, right? So they're charging between shift and then they're heading down the mine and so on. And then when we've started to explain the benefits of regenerative braking, they've then started to realize actually if they can charge the vehicles down below, that gives them a big advantage, right? Because they're then, they're starting their shift above ground with half a battery. They're coming down the ramp. By the time they get to the bottom, they're almost fully charged. They've then got their shift, and then they can charge again before they head back up. And so thinking of those different ways of arranging that duty cycle can certainly ease the adoption and provide additional benefits.
Yeah, infrastructure planning too. So where you put your loaders in underground will be likely swapping batteries for the foreseeable future. Same with trucks. And where you put charging infrastructure can be designed for intelligently. I mean, trucks haulage pathways can be routed, past charging bays. So it's a bit easier to manage for your trucking, but for your loaders, you don't really want them moving more than 250, 300 meters from the face they're mucking. So if you try to put chargers throughout your mine where your active headings are going to be, you could end up installing a lot of chargers and have unnecessary tramming to chargers to do swapping. So we've worked through doing duty cycle studies and looking at optimization with customers looking at fully electric underground mines and where they want to use battery swapping LHDs, moving to centralized charging, or creating charging hubs in the mine where you use battery transporter vehicles to relocate full batteries out to the heading, so the loader can grab a full battery and deposit an empty battery, and then the battery transporter whisks it back to centralized charging. Means that you can reduce the number of chargers that you have to install, reduce the tramming distance to exchange a battery, potentially reduce your total inventory of batteries in the system. So if you're looking at 2.5 batteries per vehicle, per loader, you'd want to get that number maybe down to 1.8 for your fleet. So rethinking operating strategies like that will influence mine design, mine layout, infrastructure layout quite a lot.
There's a question there for you, Patrick, from Andrew, about all these points you've raised around design opportunities, like I suppose, are you seeing them actually being designed or into new operations, or basically implemented out there in the field? Because I suppose it's all these potential opportunities that are out there, but whether or not they're actually examples on how they
I mean, I would say that some of these that they're not by any means my original concept. Some of these are coming to me from the mining engineers studying these problems, but they're the people that have been looking at this for 7-8 years now. So some of these ideas were coming out of Glencore and Vale and Sudbury for their deep ore bodies, rethinking what benefits they should get, what system level performance increases they should target, what changes in operations they might consider. That knowledge has started, like the concepts have started in the mining companies, just ideation. It's worked its way into the consultants. There are consultants out there that are doing detailed studies on different operating concepts, detailed modeling and dynamic modeling. I got a personal friend that in Pierre Lebrec, who I think does an amazing job of his system level modeling, especially now for electric systems and different operating models. So yeah, it is growing the capability and capacity of new thinking, and it's translating into some of these ore bodies miners are taking a different approach to their ore bodies. I wouldn't say it's widespread.
Yeah, there is a GMG paper on mine design. I forget who was collaborating on that GMG paper, but there is a white paper out there. I didn't believe it goes into a lot of depth. Haven't read it, but I did get it shared to me by a friend, and the insights were basically just around the points that Patrick was also discussing.
So yeah, and we had another question from Kevin from not long ago. Is the benefits around miners starting with the smaller vehicles like you guys sort of deal with to learn about charging infrastructure and some of those sort of nuances before getting onto the larger gear, which it sort of makes sense because it's a bit easier to handle lower needs of electricity and all that. So curious your thoughts on if you're seeing that out in the field.
Yeah, we certainly are. I mean, we've certainly had plenty of mining companies approach us where they've been given a direction where they need to look at electrification for their largest equipment, for the haul trucks and so on, and that's just too much of a challenge for them to take on initially, right? They want to develop some expertise, and so they say, hey, the light vehicle fleet, that looks like something that we can tackle much more easily, much more quickly. It's and also it's not such of a long-term commitment, again, because they're looking at those vehicles as having a shorter service life. I think they feel less concerned about taking a risk with putting capital into it, right? If they put capital into a electric light vehicle and then it didn't work out, for whatever reason, it's only sort of one cycle of those vehicles that they're sort of locked into. Whereas with a larger piece of equipment that has a long cycle life, it's they need to have more assurance that they are going to be able to have not just the equipment perform as they want, but also all the pieces that sit around it. So certainly that's part of the philosophy of why MEVCO was founded, is that we want to accelerate electrification across the whole of the mining industry. Now, we're not providing anything beyond light vehicles. Light vehicles is all we do, but we strongly believe that if we can get a mine to adopt electric light vehicles, that's basically opening the door for other vendors to then be providing electrification of other components in the mine.
Yeah, I think definitely smaller or ancillary vehicles. So a lot of these support vehicles are a slightly easier target in terms of adoption. It is not directly impacting production. Your total cost of ownership model looks slightly different, and you can get quite a lot of learnings from that. It's still going underground mine. It's still performing duties. You still need to think about charging infrastructure and design around that. there is still a battery fire risk. So the same learnings you would get from a production vehicle, just without actually having that huge impact on production. And that is always a really good case to make and an easy sell.
Yeah, and the fact that they're not production vehicles is certainly an important factor. The other is that they often operate as a pool, right? So, you know, if you've got a single, or a small number of a particular vehicle that is crucial to production, and one of those goes down, there's a huge impact. If you've got a pool of 50 light vehicles and one of them goes down, the impact is negligible. Because you've got others that can take their place. So again, we're seeing that for that reason, as miners want to develop confidence and see the technology in action and in their own environment and so on, it's easier to often do that with light vehicles or ancillary equipment or anything that isn't as production critical as sort of the core assets.
I'm curious to explore like how the BEV adoption, sort of Australia compared to US, Canada, wherever else, because I think Canada seems to have got a fair bit sort of in the deeper mines, but how are you seeing the uptake globally? Is it everyone's sort of catching up, or is it is there any trends that you see there?
I mean, we saw honestly quite rapid adoption in Canada, starting at ground zero, pretty close to us, close to our factories, and spreading out from there to out of Ontario to Abitibi in Quebec and out to BC, down into the States and Mexico. The differences, do define the adoption, though. The deeper mines, smaller equipment, especially in load and haul, and a lot of captive levels or muck to pass and haul to pass rather than haul to surface. So Australia using 60-ton trucks, 21-ton loaders, the payload and the haul distance is tougher. But the duty cycle on the other equipment, like the light vehicles, the ITs, the ancillary support, the bolters, shotcrete sprayers, doesn't really get defined by that. So there are opportunities to adopt in these other vehicle classes as the high payload, load and haul are in their stripes. However, it's a tough proposition. More than half, I think, the mining happens here in Australia is contractor mining, and they have a very tough time dealing with the value proposition because they have to wear all of the capital cost increase. They don't realize any of the energy efficiency and the energy cost reduction because there's a big saving on OPEX for electricity versus fuel. Typically, they won't wear the social benefit locally. They do wear the health benefit for their employees. But yeah, and they're expected to, maintain these very competitive schedule of rates against each other. So the landscape in North America is a lot of owner operation, and in Australia it's a lot of contractor mining, and it's shifting the mindset of what to expect from your contractors. What's the business model where they get rewarded for their success with EVs? Probably needs to change. Be my first thoughts on
it. So Brett, what we're seeing, so across the three countries we operate, Australia, US and Canada, we see that there's an appetite in all three for electric vehicles. What we're finding so much is not the difference between the countries, but within the countries. And we're finding that the more remote mine sites are less open to adopting EVs, and the sites that are closer to civilization are it's less of a risk for them, right, in terms of having something new, having access to the expertise and so on. So we are certainly seeing more interest from less remote sites than we are. What we're also seeing is we're seeing a huge amount of global collaboration. So the global miners that we're talking to, if we talk to one mine, we suddenly find that there are mines all over the world within that miner that are, that are eagerly wanting to see the results of what goes on with that trial. So they're absolutely looking to learn from other mine sites.
Cool, and probably getting towards the end of my questions and probably your time, but just on your thoughts on how you're seeing, the future for, BEVs and mining, like, how long before we sort of see it, them being more the, the rule rather than an exception, and what your thoughts around that?
Certainly in the light vehicle space, we think, over the next sort of 12 months, there'll be, a lot of trials being run, and we'll start to see those be a lot more widespread. After we get to sort of the end of that 12-month cycle of a lot of these trials, I think the adoption is going to be quite rapid. I think, with the range of benefits they offer, with the proof points they'll have at that point of the reduction in maintenance, because maintenance for light vehicle fleets is a huge issue for mines. The operator comfort, the health benefits, the safety benefits. Once they see all that, and the fact that there's a TCO model that actually supports, at least for light vehicle fleets, a lower cost of ownership over the lifespan of that asset, I think we're going to see quite rapid adoption.
Yeah, I mean, I think the trend in studies is a leading indicator too, like feasibility studies. 6 years ago, we'd get inquiries for a feasibility study with a consultant. They'd ask for our pricing and spec on diesel equipment, and then they'd say, we'd actually also like to compare it to EV. Just give us the EV out of interest. And then 3 years ago, it started to be just generally speaking, studies were coming in saying, we want diesel and we want EV. We'd like to compare both and trade off. In the last year, the first studies are starting to progress, the first RFIs and RFQs, where they don't ask for the diesel pricing, they don't want the diesel spec. So the first studies are being already committed to at the study level for all electric. And we're seeing that through our factory as well. We've progressively increased. I think next year we were forecasting we might be hitting about 40% EV build. So significant number of vehicles coming out of our factory in electric.
Yeah, for us, it's almost the same in terms of a huge influx earlier this year of interest in some form of a retrofit, especially when equipment have reached their end of life and they're undertaking mechanical overhauls and whatnot. It's the perfect opportunity for miners and mining contractors to take ownership of that and go through the path of electrifications, adopt some form of kits and so on. Huge influx earlier this year. Quite a lot of interest even in harder applications where they're demanding hybrid integrations as well. So we're seeing a lot of that come in now in terms of, this is a hard duty cycle. It is a much larger truck, but would still like to electrify it. So the conversations have definitely shifted. And I think the questions around electrification have also shifted. Before it used to be about battery fires and readiness of site and so on. And now there's quite a lot of educated questions around mine infrastructure, design, functional safety, more understanding of what that electrification integration looks like from our perspective as well. But yeah, definitely getting there. And I think there's also a lot of questions around, is it directly related to technology readiness of other chemistries? And is it directly related to some, the charging infrastructure, concepts of wireless charging and all the other stuff that are coming up now to support that larger scale decarbonisation? And I think, to Patrick's point, if it's working for you now and you're realising the benefits and it's working for your mine, then it's best to start adopting that technology early.
Oh, I think that's just about got to the end of our time and our questions. But no, thanks everyone for your time and your great conversation here. Just wanted to give you a chance. Any last sort of comments you might have to wrap things up? Anthony?
Just one last comment. This sort of contrasting with what you said, Tanya. You're obviously looking at larger equipment, and retrofitting at the time of mechanical overhaul makes sense. For a light vehicle, it's the opposite. The only interest we see in retrofits is where we're doing it to a new vehicle, because by the time it's gone through that duty cycle, they scrap the vehicle and they move on. So it's we're certainly targeting a quite a different cycle there. But look, we're hugely excited at what we're seeing. We're chafing at the bit to get time under our belt with these trials, because we know that is what's going to make all the difference. To go to a miner and say, okay, we've now got X months of these pieces of equipment being used in these different environments, in these different duty cycles, and because particularly with light vehicles, there are such a range of duty cycles even within a single mine. And the more of those proof points we can get, it's those proof points that the mining companies want, right? They don't want us to be saying, oh yeah, this is what we think, how we think these vehicles will perform. They're not interested in that. They want to know how it has actually performed in those trials. And as soon as we can get that snowball rolling down the hill, I really think that adoption will accelerate quickly. That's also part of the reason why we entered into the worldwide exclusive agreement with Rivian, because it does give us access to a much greater scale of light vehicles, right? So a retrofit program for the Hilux, we get a lot of interest in that in Australia, because of course the miners are familiar with that vehicle. It's common on the mine site. They're already set up to service a lot of aspects of it, that sort of thing. So that's all sort of within their comfort zone for an evolution to EVs, and that's great. But when they then turn around and say, okay, well now we've got 1,000 vehicle fleet that we want to replace, it's much harder to scale that up to those sort of volumes with retrofit. Whereas when we've got the backing of an OEM and we can simply turn the dial and say, okay, can we have 1,000 vehicles this month? Sure, no worries. It's important for us in terms of how we're positioning for the future, that we're able to scale up to those sort of quantities.
Yeah, I think just as a wrap-up comment, definitely want to thank all the attendees for their time and the interesting questions that come through. Really interested to see some more collaboration in the industry for sure. I think really looking forward to the improved safety in underground mines and also open pit, but also looking forward to job creations and the new jobs that will be created from electrification and decarbonisation projects. But yeah, just all in all, thanks for your time. It's been a really good conversation. And thanks for all the information you provided, Patrick and Anthony, as well. Thank you.
Thanks, Tanya. Thanks for the invite, Brett. It's good to connect and chat.
Thank you. No, thanks. Any other last comments, or we might sort of call it time there? Yeah. No.
Fantastic. Thanks for organising, Brett, and great to have an audience and all the great questions that came in. Wonderful to see them flowing in all the way through.
Yep.
Thanks.
Thank you, and good luck with future plans with your BEVs, getting them out there.
Cheers.
Cheers.
Thank you.